Can two mathematicians use maths to beat two very good pool players? On my team, I have Grant Sanderson from 3 Blue 1 Brown. I'm sure you all know the channel. We are up against Rolly Williams, who you might know from the Climate Town channel. They also have a pool channel, so I will link to that below if you want to check it out. Also on their team, and I think this might be cheating, is Jennifer Beretta, a incredibly good professional pool player. I will link to her TikTok below. But we're not going to play a game. We're going to do pool exercises, which is what you normally set up for Rolly to do.
Yeah.
And what we're going to try is you're going to set up one of them. We're going to look away. We're not going to see what Jen does. Jen's going to do the proper shot, which you will get to see as the viewer. We will then turn around. We will use maths to work out what we think is the optimal shot. We'll see if it works. We'll see if it's the same. What can go wrong?
Okay.
I can think of a bunch of things.
Yeah, I'm predicting disaster for team mathematics right now.
It's spheres and angles. How hard can it be?
Exactly.
Yeah.
Is there friction? I hope
I'm assuming not.
Yeah, I've assumed no
Assume
friction.
the radius of the cue ball is 0 and you're hitting a platonic point.
I'm not going to lie.
Bouncing off of mirrors.
There's more air in the room than I'd assumed.
Should we put this like here to make it harder for because like here they might make it on accident, but here there's no way these guys are gonna make it.
Well, how about here? This is a
Yeah.
little distance from the rail.
So you're gonna do the extra calculation.
Yeah.
Okay, great. Let's do that. Because like I just don't want these jokers to like accidentally make the
Fall
right
into
shot.
it.
Yeah.
But the thing is, they think they're playing like in a vacuum. He asked about friction. Now we know some things about how you have to hit the cue ball.
That's
Like
true.
the math doesn't make a difference if you don't know how to hit the cue ball.
But if they're wrong in two variables, they might cancel each other out. Like I think here makes it like this is a
This
tough
is, like,
shot.
really tough.
They're
This is
not
tough
gonna
for
make
me.
it.
I
These
mean-
guys have been failing up for their whole lives. I don't want that to happen on this table.
We have some inside information that mathematics people do not know.
Yeah.
Okay, so I'm gonna come out of 30, 50,
Okay.
and that should take me to 80.
Okay.
I'm just gonna find a spot on the wall. Okay, I think I got it. Do that, mathematicians.
As I heard the challenge, there was no time constraint. So
Right.
if we take a moment to just work it out.
We're going to measure up. We're going to plan. We're not going to need these for a while.
No. Not,
Right.
not for 20
do you
minutes.
Do you want to measure up?
Yeah, sure, I'll make the measurements. So the center of the ball is about 26.5 inches.
Inches?
We're in America.
Oh my.
Suck it up.
I'm just going to do a sketch for now, just so,
just a
so
quick
we've
sketch.
got it. Yeah, okay.
26.5 here, about 9 inches from this wall,
Okay, what's our table size?
about 100.4,
100.4 inches. This
Yeah.
is hurting me so much.
and
What? What?
and 50 inches.
I would like to 50 inches.
You know, let's call it 50 by 100. That's within the tolerance.
Is it 50
of,
by? I would not be surprised if it was designed to be 50 by 100. That feels about right. Feels nice.
But the bed is the playable surface, right?
It is,
So
but
what are the diamonds?
how are they gonna aim it?
Just thinking ahead.
I mean, I don't think they're going to aim it at all. I think they're going to just put some numbers down on a piece of paper and hit and hope.
I think we're going to struggle to plot these on. I think we just work out the path
right.
and hope that whatever the path is, these are arranged so it comes down the middle.
I think it's
All right, these guys are totally hosed. There's no way they were measuring the wrong part of the table, which
Yes.
seems counterintuitive, but instead of measuring the playing surface, it's helpful to
don't
measure.
let them hear you.
All right, you tell them. I don't really know.
So an error that I spotted is that we calculate through the diamonds. They calculated on the bed of the table. And that might change the angles that the ball comes off the rail. So, but we'll see.
I mean, I actually happen to know for a fact that these guys are kind of fans of the game of billiards. so they might have some natural ability. But this shot is sufficiently hard that I would be shocked if they were able to drill it.
And the other thing, this game is not played in a vacuum. There's friction. The ball picks up spin on the rail.
Yeah. When it's like more humid.
More humid. You have to
changes
change
the-
things. Like everything, every little thing changes how this works.
I heard a story of this American pro named Shane Van Boning who was playing in the Philippines. He was kicking this dude's ass until they turned on
air conditioning.
they sucked all the moisture out of the room or put too much moisture in the room or something, and he couldn't draw the ball anymore and he lost the game.
I've played in the Philippines, and when the air conditioner is not on, as opposed to when it is on, the table is just completely different.
Wow.
So it's going to be the same thing. Like if they don't know the calculation for like the friction, I don't know if math can solve that.
What we're doing is we're drawing a scale diagram of the table. Very pleasingly, we've realized we can do 1 millimeter on the page to 1 inch on the table. So that's a metric to made up units system. And what Grant's done,
You're such an imperialist.
first of all, has drawn the table as it is. But we know we got to bounce the ball off the first corner. So Grant's now drawing the phantom table, which is like the mirror universe. So instead of imagining the ball bouncing and angle in as angle out, we're imagining the ball carries on straight.
This is
another
mathematician's
table.
favorite trick.
So good.
Yeah, this is like everyone's favorite problem-solving tool, where when you have some kind of ball
Yeah.
that bounces, rather than thinking about it bouncing, saying, okay, it comes in, and there's like an angle,
Out.
some sort of angle of incidence, angle of reflection, or maybe you do those angles off
Yeah.
the vertical. You just kind of envision that it goes through to a ghost universe. And we're just gonna,
we need this table over here.
I need the other one up here.
Should we show them? You can have a look,
Can I see?
Yeah,
I'm
sure.
so curious.
Here's what we're doing. So,
You've just drawn a couple lines. You've made no progress. We drew many things that we had to scrap.
drawn the table.
Oh,
But then what we're going to do is instead of imagining the ball bouncing off the... Yep.
Can I measure your table? I'm just curious.
Oh yeah, sure. So we're going with inches to millimeters, and since edge to edge it was 100 inches, we're doing 10 centimeters there.
Is that the right size of a table?
Or is that wrong?
it's much bigger than 10 centimeters.
You got to get in that corner there.
Yes.
But instead of imagining it bouncing like this, we're imagining it traveling onto a perfectly reflected table, which means that's the pocket we're aiming for. But then when it bounces here, it's going over there. So what we're actually got to do is hit the ball into this pocket over here.
Oh, do you have your long ruler?
Oh yeah, it's a longer roll.
So you're doing
We're gonna
like
bring
a
out the-
parallel.
time for the big
this
ruler.
is called a parallel system that
Parallel
you're
system?
inventing over here. Yeah.
All right. So,
Okay, so now
Now here we go. Now here's the
This
fun.
might actually work.
Ye of
you're
little
getting
faith.
that on the record early. You know what would make this better in the edit? A 3 blue 1 brown animation. Here it is.
If we want to consider the ball a point particle, then the effective edge of the table is 1 ball radius out from the cushion. This is where the center of the ball is when it's reflected. We can then fill in the mirror table and the mirror table with their phantom mirror balls. And as the main ball moves around, we can imagine the mirror balls moving in unison. Here's the trajectory of the shot we were trying to make on the actual table. We can now move that into the first mirror table and see that that phantom mirror ball follows along that path. And we can reflect the last bit up onto the third table. And you can see that if you track from one mirror ball to another, you've effectively got a straight line. And mathematically, that's what we're trying to work out, because straight lines, far easier to aim. If we know where that distant phantom pocket is, and we line up a perfect shot aimed at it, then all the reflections, in theory, should take care of themselves on the real table and put it in the pocket. Hypothetically speaking.
I reckon we give it a go.
Give it a go.
And that way we got an excuse if it goes wrong.
Okay, all right.
Okay. So do we want to mark
28 inches.
28? My brain refuses to look at the inches. There. That's the spot.
All right. I assume this is what professional pool players do.
Yeah. Now we could even work out where the next one's meant to be. Nah, let's just do this.
We'll just take the shot. All right.
Okay. Can you give me 28 inches out?
Yeah.
Oh, we didn't factor in other balls getting in the way.
You can move it. I'll give you a slide.
Thank you. Okay.
That's my bad.
Okay, here it is. This is it. Ah, white. So I'm done with maths.
Literally back to the drawing board?
No,
or-
Jen's going to tell us how
She's
you
going to
do it.
explain
Yeah,
how to.
yeah,
Okay.
Yeah, so, well, one of the things that I feel like you guys probably don't know, I mean, you know, obviously the pool is not played in a vacuum, but there are other things happening on the table when you hit a cue ball. So when it comes long into a rail, it actually picks up some spin. So
yep.
it's going to change how the ball reacts. You can get the math perfect, but the friction is going to change the path of the cue ball.
So even if the ball's like no side spin,
It's
goes
going to
into
pick
there.
up side spin,
It's going to pick up clockwise.
running spin. So that
Running
makes it
spin.
open. Yeah.
Right.
So one of the things we do to counteract that is we actually use running spin. So when it hits the first rail, it
Yeah.
comes shorter, and that makes it come shorter through here. So your calculation might work with some running English.
Oh.
Running side.
And that's to compensate for the fact that it's going to pick up
That
spin
it's going to
otherwise.
go long on that rail. So you're making it come shorter into this rail, which kind of counteracts that.
My animation is not as good as 3 Blue 1 Browns, and not at all to scale, but you get the idea. So when we hit the ball dead on, it has no spin, which means when it hits the first cushion and bounces off it, a rotation is imparted during that bounce, which means on the second impact, the angle of incidence is no longer going to equal the angle of reflection like we had assumed, because that rotation is going to give the ball like an extra kick. It's going to open up the angle, as the pool players say. It's going to make a bigger angle. Now, to avoid that, pool players can start the ball with some side spin, or running English, or whatever they call rotating a sphere. This means when it hits that first cushion, it's already spinning to compensate for the spin it will get from the bounce. This means the angle of incidence can be the angle of reflection, or whatever sort of closed or open angle the pool players want. They're professionals. They know what they're doing.
When you say you're pulling, but you're deliberately giving a little bit of spin
Yeah.
in one direction.
Yeah.
Are you hoping that when it comes off this wall, it no longer has any spin, or that it actually, the spin that it would have?
Basically, what happens is, if you hit this with a flat ball like you did, and you hit it hard, that's the other thing. When you hit it harder, it comes shorter.
Yeah.
So it compresses the rail more and comes off straighter, right? So with your calculation, it's just going to throw the whole thing off. You have to hit it
Interesting.
at that speed where it's not too much rail compression.
Interesting.
So the other thing is, even if you do that, when you hit it into this rail and it comes long into this rail, it'll start picking up running English from this rail, and that's going to make it go where it did. It went really long. By putting running English on it on this rail, it's making it open sooner, which changes the angle and makes it come through here.
Could you try hitting our 28-inch spot?
Yeah, let me see. My spot was,
Where's yours?
where was my spot?
Should we measure up exactly where the ball was?
30, 50.
Sure.
My
Yeah.
spot is here, like on the wall, right?
Right, yep.
So mine is like here.
And where was ours?
Yours is
I mean,
like
we
right
put it-
over there.
Oh, no,
Where
no,
the
that's
chalk
moved,
is.
that's moved.
Yeah.
Oh, you
Measure
moved the
up?
chalk?
Yep.
Oh, gotcha.
were-
Ours was here.
Ours was there.
Yours was there. Okay. I
Well,
might
we aimed
be
for that
able
point
to-
there.
Yeah. Okay. So I'm like, because my spot was here and I used a lot of running English, not a lot,
Yep.
but to compensate, I can go here and use a little bit less, but I'm still going to need some.
Let me just pop it.
Oh, you know exactly where it was.
That's where it was.
Okay. So let me see.
Yes, see if you can do the shot.
Let me just find my spot. Okay, it's actually not far off from,
Oh, really?
from your spot. Yeah, it's a little bit, but not far off.
Out of
That's
this
how it's
world.
done.
Oh my god.
Okay, so you've been talking about, because you use these dots.
Yes.
Diamonds?
Diamonds, we call them, yep.
Exactly. Yep. It is a very low dimensional approximation of a diamond. So I'll accept that.
They used to be.
They use the actual diamonds. Gotcha.
A 1 pixel diamond.
1 pixel diamond. And you're talking about looking at a spot on the wall.
Yeah.
So how about you just actually teach us the technique you taught
Okay.
Rolly, and then
Alright.
we'll see if we can reverse engineer how that works.
Okay, so a pool table is half as wide as it is long.
We discovered that.
Yeah. Oh, you didn't know that before.
Did I know?
Okay, so what I do is I assign values to this rail, and then I assign double the value to this rail. So,
Right.
for instance, in this case, can you grab me the 8 ball?
Yes.
So, in this case, this is 80,
80.
right? Number 80.
Oh, because it's 8
So I divide it into 10, right?
Got it.
80, 70, 60, 50, 40,
Yep.
30, 20, 10, 0. So this rail is worth double, so the pocket, instead of starting at 0, starts at 10. 20 is halfway in between,
Yep.
30 is the diamond, 40, and 50. So now based on where the cue ball is, and I'm trying to get to 80, I look at
Right.
where am I originating and where is my destination. So I'm originating from 30, close to 30, right?
Yep.
Not
Okay.
exactly on it, and I have to get to 80. So 80 minus 30.
100.
Mathematician,
Oh, and you're 50.
50.
So you're doing
50.
that. Okay, so first of all, I was curious why you do 10, 20, 30. So you're just doing 1, 2, 3, 4.
You could, but then you get to like, when you get in between, you're at like 1.4, it gets very hard to
And
get. Yeah.
as we just discovered, it's 100 inches long. So that's the number of inches. And here, you're doing the same thing, but you're counting half inches.
And I noticed you measured the bed. We go through the diamonds.
Yeah,
Through
that's
the diamond.
really curious because
Yeah.
it doesn't bounce anywhere near the diamonds.
It doesn't, but the angle, for some reason, is more accurate through
That's
the diamonds.
we're gonna crack why because
Yeah.
that totally throws off.
Yeah.
That baffles me.
Yeah.
If anything, it feels like the opposite because the thing that's if you want like the center of mass of the cue ball, it's not bouncing off the side. It's like one radius
Yeah.
in. But not only are you not aiming there, you're
aiming way
on
off
the
to the
other
side.
side.
Yeah, we were actually aiming
That's-
at the diamond. So
And then it's got to add to 80.
it's got to add to 80. Now, one of the things that I noticed is that, okay, so we have 30 and 50, right?
Yep.
Yeah.
And
Yep.
I try to find the line that the cue ball is closest to, because
Gotcha.
obviously you also have like 40, 40, but the cue ball's nowhere near that.
Yeah.
So I pick the one that it's closest to, and then from here I'll find a spot on the wall. So I'll look at like that on the chair there, and that's actually where I'm going to aim.
The ball's not on a nice, neat line,
Right.
and so you're not allowed to move the ball over.
Not allowed to
So
move it.
instead, you look at the line, you look at where it hits across the room,
Yeah.
and you remember that point,
At least 4 feet away. Yeah.
and all you do is aim at the same point.
Aim at the same point, as long as the cue ball is near the neat line. So the neat line here is
Yeah.
the 50-30. It's so close to it. As a matter of fact, here I might not even need to do it because
Yeah.
it's so close. But even if it's, say, here, now you can do the spot on the wall and you'll still get
You
it.
still-
So, and that spot never changes when you're in this line.
Hang on, can I just grab our diagram? Give me
Yeah,
one
sure.
second.
You guys kind of reverse engineered the spot on the wall thing.
What I'm so curious about with the spot on the wall, and I think this is why he's bringing the diagram.
Yes.
Right. Like we want to envision
I
the
put
idea
that on
that.
here, yep.
Yeah, that line technically
Yeah.
goes on endlessly, right?
Yeah.
But no, not endlessly, right? Because it's as if you want to think that it's one pool table over. Like, because if it bounces and bounces, you
Yeah.
want to think like it passes through one wall, passes through another wall. So, I'm, like you said, at least 4 feet away. I'm curious if there's like wisdom around, should it be exactly like one pool table's width away?
That's exactly
Or-
100 inches, 50 inches. So you're
Yeah.
aiming at the mirror pocket. You're aiming at this phantom pocket.
At a mirror, probably, yeah, way off into
In the
distance.
upside down
Yeah.
imaginary phantom table.
As a matter of fact, this is set up perfectly, but for bank shots, the way that I'll shoot a bank on this table is
Yeah.
I'll shoot into that corner pocket to make it here. So say I have a ball here.
Yeah. Oh, and you
I'll
know
aim
that's
it-
roughly
that's
the same
about-
distance that
Oh.
way.
It's a mirror table. We call that mirror image table.
Oh,
That's
interesting.
exactly what
Yeah.
we would call it.
Yeah.
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 That's amazing.
And
so
yet,
what
and
if
yet,
we?
but you have, so that table is not right next to it. It's a pretty serious distance
But
away.
you want it to
Yeah.
be exactly
But it's
50
exactly
inches.
Is it
another
exactly-
pool table.
Yeah.
But the question is it exactly 50
deliberate?
inches or is it another
Let's find
pool
out.
table? Because
Yeah,
the
yeah,
pool
let's
table
find
is
out.
longer than 50 inches, right?
Where's our tape measure?
Okay, I can start like this. This is my thinking. Look. Okay, I'm going to propose that we mark out the exact location of the phantom pocket, and then we see what happens if all of us try the same shot. But the ball can be anywhere now, and we aim for the phantom pocket.
Cool.
And I think we factor in the radius of the ball.
Okay,
So we take 2 1/4 inches off each dimension,
Yeah.
and then we're going to put like a bright bit of like a tape or something
Okay.
exactly where it is, and then we'll see what happens.
Okay.
That works for me.
Okay, let's do
Can I make a prediction?
Again, you. Yes.
Speed, spin, and stroke
Yep.
are a huge part of whether you're going to hit it or not.
I feel like rounding errors. No, you're right. I'd be interested to see what you have to do to the ball such that aiming at the phantom pocket works.
Okay.
Because whatever you're doing is the anti-version, the reverse of whatever the cushions are doing to it.
Right.
So I think that'll be fascinating to
let's
see
do
what
it.
happens.
All right.
We'll see. So let's go this way first. If you hold that on the cushion.
Do we want it from the cushion or from like the center of the pocket? Like the.
It doesn't. I'm only doing one dimension at a time.
Okay.
So this, in theory, is 50 inches, but we want to take 2 1/4 off. So it's going to be 50, 1, 2, quarter. There. How does that feel for you?
It's the same thing. It's like basically right where your calculation was. So I'm a little
really?
to the right of it. It's the same
Yeah.
exact spot. Right here,
because
look, the
it's
top
exactly this-
was almost where it was. It's right here.
Because we did exactly that calculation.
I guess that's reassuring.
Yeah. So we got the numbers right, but we got
Yeah.
the pull wrong.
Yeah. So the adjustment that I make here is I just hit it with a little less spin. So I have like I've like from playing for so many years,
Yeah.
I've calibrated
You know
the amount
how
of
to-
spin that I need. Now I know I need a little less.
So could you try hitting that? And my camera person's going to hate me for this. I'm going to film it on my phone in slow-mo so we can
Okay.
see how the spin changes
Okay.
coming off the pockets.
So there's our tape over there. I'm going to use a little bit less spin.
Come on.
I'm not missing that. I'm not
Out of
missing
this world. Out of this world.
Here's my phone footage. Sorry for the flickering, but you can see Jen is putting more complicated spin on the ball than in my terrible animation from earlier. And after it's hit the cushion, it has a distinctly different spin.
Yeah, you've set it to close the angle in.
Open the angle.
Open it back
so I'm
a bit.
opening it on the first rail
Right.
instead
Oh,
of
there.
letting it. You don't want it to open on the second rail. When it
Right,
opens on the
yeah.
second rail, it went where you guys.
Yep.
Yeah.
That's great. I'm going to try hitting
Yeah, take a
the
stab.
wrong spot.
Take a stab.
Okay,
And now
here we
the
go.
first try.
Okay, first time.
This is not the purpose for a
First time, baby.
That looks good. That looks real good. Yeah, finally.
good.
I feel like that was like 80% pool experience, 20% maths.
Yeah, so I just wanted to see like if will it also work from back here?
Oh, yeah,
As long as you
yeah.
do the same 2 cushions, it should.
Let's see. It looks right to me. Like when I look at it.
Okay.
Oh yeah, that's on. I mean,
Rude.
you know,
The math was false.
come on.
That's friction. That's friction.
If we imagine all the possible lines that a ball could travel to come into this pocket projecting out, they're going to be like this spread of lines.
It's like a fan.
Like a fan. And then they're going to go onto the phantom table and out. But actually, you could imagine them coming out of that one.
Yeah.
So there'd be like a fan of lines coming out of the phantom pocket, and I think they will basically line up with the lines you're using. So I think that's like a number system to approximate radial beams coming out of the phantom pocket over there.
It's a 3 blue 1 brown animation of all the values in the plus system, and if we link them up with the sum to 80 rule, you can see the lines kind of clump on the phantom pocket, which if you wrap around means they all kind of aim for that main pocket, which as a mathematician you might think, well, that's not very precise, but the point is they are focusing on roughly the right area, and if you compare it to the pure mathematical version, you can see, if you look at the numbers, it's actually pretty close.
So this clump, fairly focused add to 80 rule is easy to remember, easy to use, and well within the tolerances, where professionals like Jen are compensating anyway for the friction of the table, the level of bounce in the cushion, and loads of other factors. So this method, although not mathematically pure, which I personally find disappointing, it's absolutely fit for purpose, and because it's easy to use, it's probably preferable. This is a really nice, real-world use of geometry. And if you want to see more ridiculous geometry involving pool, this story and more are in my book Love Triangle, which came out in the UK this week. It's now available. It will be out in the USA on the 20th of August. As well as talking about this game that we played in Brooklyn, I talk about all my favorite bits of geometry, trigonometry, some Fourier analysis. If you've enjoyed this video, I think you'll enjoy the book. Signed first editions, available on Massgear, although it's cheaper elsewhere. Thank you so much to Jen Beretta for inviting us down to your pool hall, Skyline Billiards and Bar. Bar and Bill, that's what they call it here in Brooklyn. They don't. If you're around, do drop by, and your TikTok. We'll link to that below. If you want more pool tips, Rolly, thank you so much.
Thank you for having me.
We'll link to your average pool player series below, and you do climate.
Oh yeah,
Climate change
I'm big into the climate change. I think it should stop, and Climate Town is the channel. Consider checking it out if you're totally free.
Honestly, if you like stand-up maths videos, you will love Climate Town. I will link to that below. It's true. I enjoy them. And I make videos I enjoy, so it all checks out.
Thanks, man.
And Grant has 3 blue, 1 brown. I'm prepared to say the best mathematics channel on YouTube.
No.
I think
Silver
it is.
medal.
It's up there.
Less personality.
Number 0. It's all voice and animations. That's great. If you like the animations that I assume we made in the future and you just watched, you will love 3 blue, 1 brown.